Hi, everybody. It is hard to believe, but this is our week 6 video, and we will be moving on to Unit 7. And realistically, this is really Unit 7 and Unit 8 because modern physics is going to be comprised of what we traditionally call modern physics, which is going to look at the quantum level. We're also going to look at nuclear physics, and then once both of those units are done, we will look at special relativity, but we just kind of lump that into one as all just modern new physics. Not necessarily new, but new to us as we're continuing to learn and grow in this vast field. One of the things that you're also going to notice with this week and the beginning of next week is that things are going to move very quickly. The AP exams have been moved from their original date, but the AP Physics 2 exam is still May 13th, which surprisingly is very soon. So sometimes it feels like the days are short and long, but either way, April seemed to kind of fly. And we are already going to be halfway through May after this week. So things are going to move rather quickly this week. And then once the AP exam hits, we'll slow down a little bit and then start to look at that fun topic of special relativity. So what you're going to notice this week is that it does start very similar to how magnetism did. This is a 3-day lesson where you're going to look at chapter 27 and chapter 30. You will notice that we are skipping around a little bit, but these are the two chapters that are most important for the AP exam. So this is going to be the real kind of what we consider the modern unit, where you're going to look at energy on a different scale. And then chapter 30 is the nuclear unit, which nuclear we see a lot more on the AP exam than we do kind of any of the other modern topics, but it's a really easy mathematical question to answer. Conceptually, there are some things you have to think about, but when you get a nuclear question on an AP exam, it is a very kind of straightforward, simple math question. So those are kind of the ones that we do like on the exam, and you will see that as we go through. So what you're going to do is you are going to read those two chapters, and you are going to be making an infographic, one for each chapter. So you will have two total infographics. And then the directions are right here. I do expect you to have at least 8 key conceptual pieces of information. When you're reading these chapters, especially chapter 27, which is kind of cumbersome, your focus should not be on any instruments or the hard hitting applications within a lab. What we're concerned with is the content, the theorems, and the math. So don't kind of get yourself bogged down with what is a cathode ray. Read it, but don't spend a lot of time on the various instruments. Really, we don't see them outside of a lab. So have those two infographics, and in the past we did use Canva. I was kind of expecting you to use Canva again. In the event that you want to use something else to form the infographic, I do just ask that you send me an email, let me know what you want to use, and then I'll just kind of check it out, make sure that it'll work, and then you'll be good. So to kind of keep you on track this week, Monday you will read chapter 27. Tuesday, you will read chapter 30, and then on Wednesday, you have the full day to make the infographic. Now, you're probably going to be making the infographic along the way, but do know that you have those 3 days in order to work on this mini project. I do expect, though, that you have the infographics emailed to me via a PDF by midnight on Wednesday, because I will be sending you an email Thursday morning with everybody's PDF, and kind of just like we did with the Ignite presentation. And then on Thursday, this is where you do have a little bit more than normal. On Thursday, you will view everybody's infographics, do a little paragraph length response, or I set a bulleted list for this one. I'm kind of fine with either way you want to present your findings, but like always, reflect on your takeaways. What were some things that were similar, different? Did you skim over something that somebody else didn't? And kind of vice versa. So that'll kind of be our standard. But then do notice that I also have here some intro problems for nuclear and then some problems from the past exam. So here are some AP problems to get you started already this week, rather than doing one full week of info and then one full week of AP problems. Unfortunately, due to our time constraints, we just don't have the ability to do that. So you'll have that on Thursday, but do remember that on Friday, you'll use this to catch up on anything that you need. So it's pretty likely that you may end up having to do maybe one of these problem sets on Friday, whatever it happens to be. But then on Monday and Tuesday, you will have just straight up AP practice problems. And then on Wednesday, that'll kind of be back to relativity because that will be our AP day, or I'm sorry, the College Board's AP exam day. And that is when we're supposed to have our content covered in our class. So I do still follow those guidelines regardless of if people take the exam or if they don't, because we still have kind of our guidelines on the teacher end of what we need to follow and what we need to get accomplished by certain days. So we will have all of our content done by the not Wednesday, but the following Wednesday, and then we'll move into some pretty neat topics. Not that these weren't neat, but I may be a little biased, and I think special relativity is a really cool topic. So, like I said, we'll move on to that afterwards. Sorry that this week goes a little bit fast, but we will have a little bit of a breather after this week is done. All right, good luck this week. Email me if you have any questions.